Oh, I like this though. Oh, look at how beautiful this logo looks. Ah, hello and welcome to another Solana tutorial. This is episode 2 of the Solana Program Security series. Yes. I feel the pollen in my throat. Today we're gonna talk about bumps again.
And a little bit about types, like account typing. And the way I want to structure this is, again, I'm going to write a program which will have an exploit or two, and you will get to figure out what the exploit is, and then we together discuss how we can exploit that program. Does that sound good? Let's do it.
Yeah. This is the program from yesterday, from the last episode, our super secure program. We're gonna change it a little bit. We're gonna basically throw out what we had and build something new. And I'm gonna make it super obvious. Like, I'm gonna make what I want to teach you like super obvious, such that it's clear to you what we're doing here. Those kind of errors can come in many shapes and sizes though. And must be honest, the one I'm talking today is actually quite a niche thing, but I do want you to know about it. Like, it doesn't usually come up. Like, it's unlikely to come up by itself, but if you're unaware, then it could have severe consequences. So it's just one of those things that I want you to know. Stop talking so abstractly, Andy, and make the stupid example. Okay, I do the example. It's not stupid though. So we're gonna throw that out. That's also providing a bump is a stupid idea. We learned that last time. So where do we start? Maybe start with accounts. There will be a user account. I don't know what's gonna be in there, but definitely the user and some, I don't know, user data, who cares? This is whatever the user needs, right? And then we're gonna do an admin sign up. This takes an admin. This time we're gonna let Anchor do it. Init payer is the admin himself. Space is 8 plus 32 plus 1. For now, because I'm too lazy to provide good data. What else do I need? The system program. That's there. Okay, cool. And for the admin account, we use the seeds. This is a user admin because it administers the users or whatever. And we put the admin as key as ref also, because there can be several admins. So I want to put the admin here as well. But every address can only have one admin account, so I don't put anything else there, except the static user admin thing that should distinguish it from like other PDAs. Cool. Bump we don't provide, we learned that last time. We use the canonical bump. Okay, and this will then be a normal account. And since the admin is also a user, I will give it the user account. Admin. Yeah, whatever. The pair specified for an init constraint must be mutable. So you're complaining down here that up here I don't have mutable. Yes, okay. Sure. We make this signer mutable. Good. That's how the admin is created. And we assume that we have an admin signup that takes those accounts, and we assume that there is some kind of implementation here that does all the checks that only valid users are allowed to sign up as admin. We're not gonna call this one. That's why actually I'm just gonna error out of this. Damn it, how do I get to program errors? Oh, okay, fine, because I don't find them, I'll make my own errors. A public enum. I just throw not implemented yet. Error, wait, error. Ah, god damn it, I just gotta look it up again. If I do it enough times, I will know it, but right now I don't. Error code, and then here I can provide a message. I'm not sure if I need to do that though. Okay, but what's the problem then still? I'm just gonna see if it builds anyway. Yep, builds anyway. It's just something with my local setup that doesn't. Whatever, it's just gonna. Anyway, I mean, this is all red, which I don't get why. Something, my setup, doesn't matter. Let's pretend those red lines are not here. And let's also pretend that this would be implemented and would do the certain checks that only real admins are allowed to have admin accounts. Moving on to a user account. Gonna do the exact same for a user. So user sign up accounts, and then the user account. And as for the seeds of this program, this one gets different seeds now, obviously, because otherwise
the accounts would be the same, and such that they're
not the same. We provide them with different seeds. This one is user and not user admin, so a completely different seed here. And we also take this one, but we say that each user, I mean, that's a bad example. Anyway, we still do it like that. Each user is allowed to have several user accounts. Maybe they have different identities. You know, like with Bubblegum, a user can create several rule sets. Here, the user can create several. And to allow a user to have several such user accounts, we just add another seed here, like the name of this specific account. So we again add instruction data, the name, and then we just add the name. Man, I keep forgetting how those functions are called. It was s bytes. You know, a user can have a different name. We add that as a seed, and then a user can have several user accounts. Perfect. Exactly what I want. We copy a sign up, user sign up accounts, and literally all the user sign up does in this case is create the account, and then it could write something into the account, but like all I want to do right now is just return okay, because it's enough for me to just create the account. That's fine. That's the sign up, and then we'll do some function that actually does some stuff. How do we call it? Do stuff. Foo bar. I'm so creative. That's why I'm not an artist. Actually, let's make two separate functions to be more secure. One for the admin and one for the user. So let's make a do admin stuff. You have all the power to do stuff. And here we would do stuff that only admin's allowed to do. But this is just an example. So essentially that's where we want to get to as a hacker. And then we would have a do user stuff, which insert Nelson meme. You're just a user. And then we do user and admin, lots of copying here. But yeah, I mean, then essentially this is gonna be the same. I just realized I forgot something. I forgot to add the name here for the user sign up. We of course need to provide a name. User accounts, the user do stuff accounts. Essentially, again, just the user. This time it doesn't need to be mutable. And we don't init it anymore, but we still check that the seeds are provided. However, I think I would make it mutable. Probably want to do something with the user account. And we also don't need the system program anymore. And we do the exact same for the admin, except this time not a sign up. And we don't need to have this one mutable, but we check that the admin is still the signer here. This one still corresponds to this one. Admin must sign, and this account must be present. That's the important thing. That's how we check that an admin is actually an admin, because an admin is only an admin if it has an admin account. Don't need the system program, right? So the opposite way of what we did yesterday in the last episode, because there, if the account existed, then we said this is already done. And here we say only if that account exists are you allowed to proceed. Because if this account doesn't exist and I have it mutable here and it doesn't find such a user account here for the admin account, then here it will say a constraint is violated. Anchor does that check for me. I could do it manually to check if the account is present, but Anchor does it for us. And we are sure that it's an admin account because we used the seeds for the admin. Let's see if that builds. Yeah, it builds. Okay. So look at that. Just a little program with a bit of duplicated code. And my question to you, dear students, what can go wrong? Many things can go wrong, but what's the obvious thing that you as a hacker would now do in order to be able to do admin stuff? You can already start thinking about it while I build the script to interact with this program. Oh, actually, I also need to deploy this program. Hint, hint, the error lies somewhere here. I mean, there are several ways how we can mitigate this, and I want to talk about both of the two strategies. If you manage to identify one strategy, that's already enough. If you identify both of the strategies to mitigate the error, then you get an A+. Yeah, essentially, I need my Solana test validator. Oh, sorry, my bad. Oh, did I record the entire thing without giving priority to recording? Damn it, that means I've been laggy all the time. I was already wondering why my program is so fast. So, sorry for the lagging in the past. I just didn't give enough priority to my recording. Oops. I know that it's annoying to watch this, and I hope it wasn't so bad. Anyway, we've got a local test validator. Let's anchor deploy. Voila. And let's go to our hack. Before we actually hack something, let's do the intended stuff, and then later we do a hack. So the way this is intended to be used is we call the method user sign up, and we're going to sign ourselves up as a user with the name of my first user account or whatever. Yes, nice. And the accounts, yeah, this is pretty much the same as last time. We provide the user account. We don't even need to provide the system program because that's also auto-derived. And also our user account is auto-derived because I have seeds on. So everything fine here. And then I just send this and I create myself a user account. Once I have a user account, I can do user stuff. Again, I need to provide the name, not the system program because it doesn't need that anymore. And then I can also log this transaction. And yeah, that's the intended stuff. Let's execute that to see if that works. Now this is slow, but at least my video is fluent. Gotta set priorities. Literally, user account creation has worked and doing user stuff also worked. 66. There we go. So if we Solana confirm this, then we see in the logs here, do user stuff. We're just a user, but we did the user stuff. Cool. Now, if we were to attempt to do admin stuff here with this user, this won't work because we don't have an admin account. Try admin stuff. We just do admin stuff. Doesn't take any parameters. So the accounts that this needs is the admin and the admin account. The admin account, it can auto-infer, and we just need to provide this one. And this will of course fail because we don't have an admin account as this user. And fail. Wow! Am I on time? Yeah. An anchor error, account not initialized. Pretty obvious what's going wrong there. But that's exactly the intended behavior that I as a dev have set. Yes, I could have made a more speaking error message or whatever, but the way it works is just if the account is not there, then you're not an admin and then you're not allowed to do admin stuff. Okay, cool. That's the intended use. Now, for you little hackers, how do we hack this? How do we now get access to the admin stuff? And really, I mean, if you look at that, it should be fairly obvious. It should be fairly obvious what we can do. I mean, two things. No, as a hacker, it's just one thing. We can prevent it in two ways. So, as a hacker, what do you do? 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 Do you have it? Do you have it? Write it in the comments below. No, you don't need to, but like for your learning experience, it really makes sense for you to think about that first. If you need to pause the video and really think about it, go to the GitHub and look at the source code, compile the program yourself, and even try it out yourself to hack it. And then come back to see the solution. Unless you're like, yeah, that's easy. I can do it myself. I don't need to watch the rest of your video. Then fair enough, you don't need to watch the rest of my video. But please go and actually try it out if you're right. because you really learn if you're wrong. And sometimes you might be. This is so easy that I don't think you are, but yeah, you could be. Now, what is the problem here? What is the problem here? Let's get to the solution. The seeds are just a list of bytes. That's the one thing that you need to get into your head. Even though they are provided as a slice of a slice of a slice of U8s, really what they come down to is just a massive slice of U8s. Because all those individual parts here, this, and this, they are just concatenated. Wait, I should do it like this. They're concatenated after each other, and you can't really tell where the things in between are. So, let me make this a bit more obvious. This thing here is the same thing as if I would do this thing here. Even though I now provided two things in here, the bytes are still the same. First I take those 4 bytes, then I take those 4 bytes, and then I take those 32 bytes, and then I take this 1 byte. So this is the exact same as this. Now, can we already see the problem? We have conveniently or stupidly here, we have the same first 4 bytes as here, and then we take user input as our seeds. Can we already see how this is not ideal? So, what do we need to do to get ourselves an admin account? Well, easy. We just need to provide the right bytes here, such that all of those are equal to all of those. So what do we need to put here? Yeah, well, just admin. Let's try that. Let's do the actual hack. The hack is the exact same as above, except we don't use this weird name, but we say admin. Oh, that's actually 5 bytes. I'm not good at counting. So if we have the name admin, then we create ourselves a user account, again, because the sign up admin, we can't use that, that's not implemented yet. But with a user sign up, we actually create an admin account. And then we can again try the admin stuff, and this time it should work, because even I won't change anything here, but this time I will have this account, the admin account, because it's created here. Let's see. Clear. Go. Oh no, that's not good. I know what I did wrong. This is, of course, I should of course have awaited this. And now, but I can't await on top level. So what I should have done is call try admin here after I've awaited this. And now it probably already created this account and it can't do it again. Let's see. I might need a new user. But then the hacking will work anyway. It's just the first one that doesn't work. If it gives me a 0x0, then yeah, 0x0, because it has already created it. Just gonna quickly get myself a new... Give me a second key pair. Quickly do it all in once. Just to demonstrate that it actually works. Hehe, and it's so funny how I can just pump 100 sol into this key pair. Just because. Try again. So this time, completely new key pair. It doesn't even have a user account yet. Let's do the hack. So first create this admin account. This user account that is actually an admin account. The program expected this account to already be initialized. My hack still didn't work even though I created the account. Could be that we didn't wait long enough. That didn't have the state yet. But now that we have created that account, let's not do the hack, but let's just try the admin. So let's just do the admin stuff. And this should now work because the account was created up here in this transaction. Let's see if it works. This is the interesting part. Does it work or does it not work? Come on, tell me. What is it? Does it work or does it not work? Am I a hacker? I am a hacker. Yes. Look at that. Look at that. We have all the power. All the power of the admin, even though we're definitely not an admin. We should not have this power. So what we're doing here with this user admin is really not so smart. Now, how do we fix this? There are many ways how we can fix it. Let's start with the maybe most obvious one, but least effective. One way is to remove this user name here. Now we just have admin. And for somebody to fake this account, so to get those exact seeds, it would need to start with admin. In this program, it cannot. So now we're safe. Now you can't hack it this way anymore. There's no way to get those seeds from those seeds because they always start with user, and even the first byte is already different. So you cannot get that exact list of seeds anymore. Or you don't even need the list of seeds, but the bytes. However, it can happen to you that later at some point you create another account where you're like, oh, we just do the name and the user. For some reason you don't have an initializer here, right? And boom, we have the same problem. We could use the name admin again, and suddenly we have the same seeds. And by the way, this is not just if I provide the string here. Like I went with the most obvious example how I can fake this. I can also fake something else. Like, let's say this was my admin account and this was my user account seeds, where I just have the string. I can even fake the public key of the admin with the same string. I just encode the bytes of the public key into my string. Doesn't look good, but who cares? It's just data that I sent in my instruction anyway. And suddenly I can get to the same seeds again. I just do admin and then the 32 bytes of the public key of me essentially. And voila, I have the exact same, and I have an admin account again. So it's not just strings that I can fake. I can fake any data, any kind of data that is in here with a bump. And also the other way around, if my keys are not checked, I could also provide something else here. But in this case, I actually need to sign, so that makes this part relatively safe. So I can't just spoof any other key here. But if that was an unchecked account that is not used, then I could also, play around with them and therefore have different seeds in here. But they are limited in their size, so that's always exactly 32 bytes. There I can't just make them more or less as I could with a string. Yeah, so the string is the most flexible, and strings are still used to derive bumps. Yeah, so this strategy is not the safest, so I'm gonna remove it again. I mean, we could decrease the likelihood of such an attack happening by using several of these. Like we could have one here and one here. That would also already mitigate this attack, because even though we could provide all of this in one string, we could put all of this in one string, even if the user was not here, even if we had something like this. We could provide all of this inside this name, so encode the public key as well, admin, public key, admin, but then this one still takes another public key, which pushes us away from the same seeds that we needed for this one. So in order to get there, now we would need to have something like the user can make some name input here and some name input here, which the likelihood that suddenly happens in your program is, rather low. But then this also doesn't look too good. And still, it's just something to keep in mind, that if you rely on security just by the seeds, then you really need to make sure that the seeds cannot be faked to get to the same sequence of bytes. And again, I assume that most programs don't rely on PDAs to do those checks and do the, if the account exists, it's an admin kind of a thing. But it could be. Like if you're just starting out, you're like, yeah, it's a PDA, that's safe because it can only have this address. Then, be a bit careful with that. Now, the real and clean way how we can really make sure that this does not happen is to use types. Typed accounts. You might have already realized that I'm doing an admin account with a user account. Maybe it would be smart to have a distinction here. Even if the fields would be the exact same, that I would make a separate admin account, even if it holds the exact same data in here, have a different type such that Anchor provides you with a different account discriminator. So the first 8 bytes will be different. And then here make sure that this is an admin account. And also for the admin sign up, we create an admin account, because then we're safe, even though we might have those seeds as before. Since we're now checking for this account, Anchor makes sure that the discriminator is correct. So it is of that type, and I can't just fake the type of the account as well. But that is a whole different chapter that also James talks about in the Solana development course. Type cosplay, he goes into much more detail, also how it's done in Rust. If you don't have Anchor, that you need to have a discriminator, some discriminant here, to be able to distinguish between accounts. Yeah, so again, I can encourage you to go through that. But essentially, what we need to know is Anchor does the check that this account is actually of this type, so it must have been created as this admin account, and only then can you use it as an admin account. And this makes our hack impossible now, because we can only access this thing, and here a user account is created, and then that doesn't work anymore. We can still create the user account at the address where the admin account would live. That still works, but then it's still not an admin account. So if we now do our hack, wait, first gotta deploy success. Let's make ourselves a third key, airdrop myself to this address. And if we attempt our hack again now, come on. Oh yeah, I'm waiting for finalize. That's why this is taking so long. There we go. We were able to create the user account at the address of the admin account, but then still we get this at the do admin stuff. The discriminator did not match, because obviously this is now just a user account, and Anchor makes sure that it is actually an admin account. That's the safest way to play this, by doing types for our accounts here, because then it doesn't matter when the PDAs overlap. It's still good to know about this, because what are the implications now that a user accidentally created his account at the same address where the admin PDA usually would live? This user cannot become admin anymore. It's just impossible, because that account is already taken. Even if that thing was implemented, even if that was okay, this user cannot sign up as admin anymore, because that account is already taken, which is less severe of an issue, but maybe still an issue. Especially because then you have this weird edge case for one user that cannot sign up as an admin, even though for everybody else it works, and you don't really see what's the problem. He just chose a weird name for his user account. He wanted to be creative and call it admin. So the admin sign up, admin is this guy. So if this guy now wants to sign up as admin, let's say he's allowed to. There we go. As expected, we get a 0x0 because this account is already in use. Because this user is stupid and used the wrong name. No, it's never the user that's stupid. It's always the dev. Always assume the most stupid user you can assume as a dev. That's a good rule of thumb. If the user can break something, somebody eventually will break it. So, better design your application to handle that. And in our case, that means, using better seed setup here. This already makes it a bit safer and circumvents the issue that we have now. And with those different seeds, now this one user can also sign up as admin, because he has no way of faking the first few bytes here, or accidentally providing the exact same first few bytes here. And with that deployed, also the admin sign up will work again. Kaboom. Wrong direction. Boom. Cool. I think that's all I want to do today. Commit this, and you can find all of that on GitHub in the corresponding branches, if I don't forget to push all of them. And yeah, this has been episode 2 of talking about Solana program security here on Solandy's YouTube channel. Speaking of, you might want to subscribe and like this video and then check out the other ones. This is the first one in the series. I usually put it here, and this is one that YouTube recommends to you. And you can, of course, also subscribe here to my several channels. And then I will see you in the next video. Yeah, because we love to make videos about Solana security. Yeah.